So this is the GATE 2017 question 14 that which came in set 1. The question says the wastewater from a city containing high strength of biodegradable organics is being discharged into the flowing river at location X. So at location S, if the rate of aeration of the river water is lower than the rate of degradation of the organics, then the dissolved oxygen of the river water first point is lowest at point S. Second option is lowest at a point S, at lowest at a point downstream of location S. Third option is remains constant all along the length of the river. The last option is lowest at a point downstream of location S. Since the question is asking about the where which point the dissolved oxygen will minimum, we should remember the concept of the DO-SAC curve. So based on the DO-SAC curve, so if we plot the DO-SAC curve, so okay, so this will be linear. So this is a saturated DO. This point is a saturated DO. Okay, so so when so this point is divided into several sections, which so the first section which we called as clear water. Here the water is clearer water. Okay, now the sewage is added at this point. Here sewage is added, wastewater. As per the question, it is the wastewater is added. Wastewater added. So the x-axis. So x-axis is the distance. So now based on the question, so here saying wastewater from a city containing high concentration of body is being steadily discharged in the flowing river water. Okay, at location X. S. So basically this is the location S. So where the waste earlier it was a clearer river water is flowing, then the wastewater is added at point S. So then where the DO will be minimum. So you can see in case of DO sac curve, first there is a clear water, then this zone is known as zone of degradation. Zone of degradation. Okay, and this zone is known as zone of active decomposition. Zone of active decomposition. Okay, so and this zone is known as zone of recovery because the DO is again rising. Initially it was at saturated DO level. When the wastewater is added, the DO declines. At point it becomes minimum here, then it again recovers. So this is known as zone of recovery. We call it as zone of recovery. So zone of pollution in river water stream is first is zone of degradation. Okay, so zone of degradation, basically this is found up to certain distance downstream of point at which the sewage is discharged into the river. So this is the zone of degradation. Water becomes turbid and dark in this zone, and DO reduces up to 40% of saturation. That is the zone of degradation. In second case, that is zone of active decomposition. In case of zone of active decomposition, it is a zone of heavy pollution. So it is a zone of heavy pollution. Okay, water becomes turbid than the zone of degradation. So this is the main point. Water becomes turbid than zone of degradation. Okay, fish will disappear. At the end of the zone, DO concentration will reach up to 40% of the saturated DO. So here it is the DO minimum. So DO minimum at this zone it will reach up to 40% of DO. 40% DO. Okay. So this is the point where the DO level will be minimum. And other is a zone of recovery. This is a zone of recovery because the DO level is rising now. So DO content rises above 40% of the saturation value. And after this zone, this is the zone of clear water. After this zone, this is called a zone of clear water. So basically, there are four types of zone. One is zone of degradation. Second is zone of active decomposition. Third one is zone of recovery. Here BOD falls down. And the fourth one is zone of clear water. Okay, so now coming to the question says the wastewater from a city containing high concentration of biodegradable organics is being steadily discharged at a flowing river at location S. So this is the basically location S where the wastewater is added. Wastewater is discharged. So you can see the DO level is minimum at some point of the downstream of location S. So based on the option, the first option is lowest at location. This is wrong. Is lowest at point upstream. It is not upstream saying it is also wrong. So third option is remain constant. This is also wrong along all length of river. The fourth option is lowest at point downstream of location. This option is correct. So basically, DO level is minimum at some point of downstream at some point of downstream of location X. Location X. So at this level, at downstream of so if the rate of variation of river water is, so again in the question they are saying if the rate of variation of the river water is lower, rate of degradation. So basically at so basically the DO will be lower at this point, some point of the downstream of location X. Okay, thank you.